Singapore's National Water Agency, PUB, is using a network of real-time water quality sensors to monitor illegal discharge from companies. Such waste, known as straight effluent discharge, could endanger the health and safety of workers. As Rachel Teng reports, such illegal practices can also disrupt used water treatment processes downstream.
These are the eyes and ears that help detect illegal discharge from industrial firms. There are more than 150 electrochemical sensors island-wide to help detect heavy metals and other toxic chemicals in water. And over 100 remote monitoring units deployed across Singapore will sound the alarm if illegal organic substances are found. Singapore has no freshwater sources of its own, and so keeping its used water supply free of toxins is crucial. As Singapore's population and trade activities grow, its water demands are set to double by the year 2065. Now, treated used water or new water will be increasingly important for helping Singapore achieve water security. PUB prosecuted 90 offenders for close to 300 trade effluent-related charges from 2017 to 2023. On average, about 70% of the cases are repeat offenders. To deter them, the Sewerage and Drainage Bill was amended last month to allow the use of GPS tracking. There will also be stiffer penalties. For instance, discharging trade effluent without prior approval did not carry a minimum fine previously. But now, first-time offenders could be fined at least 4,000 Singapore dollars.
Our legislative power includes the Sewage and Drainage Act and Trade Effluent Regulation, which require businesses to submit their detailed application plan to discharge into our system.
One industry player says Singapore is dealing with more complex types of waste over the years. Treatment processes may need up to 5 steps, up from just 1 or 2 steps a decade ago. For instance, acidity levels, or pH, may also vary.
It used to be easier to treat for all the wastewater streams from the industries. So currently it can become high pH or low pH wastewater coming with organics inside. So from this volatility, it's difficult to do a treatment. That's why there's no one-step treatment now.
He says pharmaceutical or special chemicals plants often involve more complex waste types, but that the key is to keep up with tech advancements.
And here to explain what this means for Singapore's waste management processes is Associate Professor Olivier Lefebvre from the Department of Civil and Environmental Engineering at the NUS College of Design and Engineering. Professor, thank you so much for joining us this evening.
Thank you for inviting me.
Put it into perspective for us. Why is trade effluent management so important for Singapore's water security?
Well, put simply, first of all, water is very important in Singapore. And it's very easy to forget it because we seem to be surrounded by water and it rains a lot, but really water is a problem because of our density of population and the lack of storage facility. We don't have enough land to keep all this water. So this makes us equally water scarce as the Middle East countries. Mm-hmm. Now, the second thing that you need to know is that those trade effluents or those industrial use water, they represented already more than half of our water supply 10 years ago. Water demand, sorry. By 2060, according to PUB, it will be 70%. So it means that 7 drops of water out of 10 will go to the industry. So I think once I have put those numbers, it's very easy to understand how it's impossible to secure our water cycle without handling those very challenging type of waters.
But help us understand also just how harmful is trade effluent discharge and to what extent does it endanger our safety and health?
It doesn't directly endanger our safety and health because it's treated. The problem is that very often our used water treatment plants, they are not specifically designed to deal with those very challenging molecules and the very high concentration. So it means that for this reason, those industries that generate those very complicated, hard to treat type of waters, they need to meet specific water quality requirements. If they cannot meet it, they need to have their own used water system at the company before they are allowed to send into the sewerage system. Once it's there, then it gets further purified by our very centralized water treatment system. So it's not that we cannot handle, it's about the quantity and it's about making sure that it doesn't release, that it doesn't get discharged untreated, where then it could affect the health and safety of the workers, and also where it could disrupt the proper functioning of those used water treatment plants. So either the companies, they are able to meet those discharge qualities, or they have to give those, they have to hire toxic waste collectors in order to safely handle those chemicals. So they will not enter our water supply, but for the companies, it's a burden. It's an economic burden.
Okay, if I may just interject, under our current regulations, businesses need to submit their detailed application plan to discharge into the systems. What are the challenges that companies face with keeping track and properly disposing of new chemicals used in emerging industries? Okay,
first of all, new chemicals are very difficult to keep track of. Every day there are about 15 to 20,000 new chemicals that are registered in their databases. Every year there are thousands of those chemicals that make it to the industry. So understanding how each and every chemical is going to affect us, or how each and every chemical is going to be degraded in a used water treatment plant, is impossible when there are so many. So it means that we need to have non-discriminative technologies that are able to tackle almost any kind of pollution at once. And the problem is that those technologies, some of them, they can work in a lab, but it takes a lot of effort, it takes a lot of research in order to bring it to those companies, make it economical and make it easy enough to handle, that they will be able to handle it in their own used water treatment plant at the industry when this is not their primary business.
Okay, are there any skills gap or manpower issues that need to be bridged here?
Yeah, those are the ones that I was mentioning. All those technologies are a bit difficult to handle or to understand by non-specialists. I'm talking about things like membrane bioreactors, ozonation, advanced oxidation processes, all those very complicated technologies. So it means that we need researchers to make those technologies more affordable. We need entrepreneurs, or I want to say hydropreneurs, in order to bring them to the real world. And we need the engineers who will be able to operate those technologies at the site.
Professor, we appreciate your insights. Thank you very much for speaking with us. That was Associate Professor Olivier Lefebvre from the National University of Singapore.
Thank you for having me.